All right, so we're going to look at an introduction to vector functions, a really cool application of vectors and very useful, I would imagine, in for all sorts of applications. So let's just have a look. I think the best way to explain this is with an example. So how we would read this is that we've got some vector a of t, and the x position is given by 3 plus t. Remember, this I hat here represents a vector in the x direction. And then 1 minus 2t j hat. Now, j hat is the vector to be taken in the vertical direction. So this is our vector, and obviously it depends on this parameter t. So at the moment, you can see that we've got t set equal to 0. So what we would say is, let's just work out the horizontal component of our vector. So 3 plus 0 is 3. So we have moved 3 across in the x direction. Okay, if t is 0 again, 1 minus 2 times 0 is just 1. So I've moved 1 up in the y direction, which is why this vector is pointing at the coordinate x being 3, y being 1. Okay, if we were to sort of express that vector in a different format, we could say this, you could say that x is equal to 3 plus t, your x coordinate is equal to 3 plus t, and your y coordinate is equal to 1 minus 2t. And then this is just saying I've set the slider between -10 and +10 for t. Okay, so what we can say is x equals 3 plus t, and then therefore t equals x minus 3. And the reason we're doing this is because what we want to do is we want to come up with the equation for the curve that this vector will trace out. So I'll just show you. This vector is going to trace out. Hopefully you can see that would trace out a linear line. If you were to plot all the endpoints of this vector, it would plot a linear line. So what our job is to find out what that line is. So what we're going to do is going to rearrange for t. So we're going to get t equals x minus 3. And then we get y equals 1 minus 2t, but we know that t equals x minus 3. So we're going to substitute in x minus 3 into there. So we get 1 minus 2 multiplied by x minus 3. And then so y equals, if you expand this out, simplify a little bit, you get negative 2x plus 7. And sure enough, if we sketch that graph, you'll notice that this vector is always going to sketch out points that lie on that line, negative 2x plus 7. So I think it's a pretty cool application of vector functions. And that's just sort of hopefully an introduction with an example to get you thinking about how vectors can be defined in terms of this parameter t. Now, you're probably thinking, what could that parameter t be? Well, generally speaking, it's time. If you're talking about the position of a particle, then that parameter t is, at time 0, your particle is at an x position of 3 and a y position of 1. At time 1, it's at 4, -1, and so on. So you can sort of use it to solve a bunch of physics problems, I would imagine. So hopefully that makes some sense, and good luck with all your studies.